Hello everyone, welcome back. This is Sunny here. Until now, we were discussing about the basics of Python programming and all. We have seen in the last videos, we have seen in detail about the Python functions. And here always, what I'm going to discuss is about the Python modules and packages. It's a simple topic. If you know until Python functions, it's going to be a very simple topic. What Python functions are, and let's go ahead and see the difference between Python functions, modules, and packages. Okay, so our current topic is modules and packages. This is not a detailed syllabus, but it is mandatory. It's a very important topic that we need to understand, because moving forward in real time, we are going to do Python modules and packages too much. Whatever we write will be writing as a functions. Those functions will be called in different modules, and we'll be creating packages. This is how this flow is. Let's first of all, let's see what is meant by module, what is meant by packages and all. Okay, first of all, what we see so far is Python functions. Functions, we created functions to reuse the code. Okay, reuse the code or code reusability within the same Python program file. Same Python program file. This is what this function is doing. Now, suppose I have some other Python program file. Suppose I have abc.py file. This is having some functionality. And after that, I have created xyz.py file. I have some functions here. Okay, some functions defined here, and I can use those functions within this Python program. So now there is no issue with that. We can call wherever we need. We can call that function with a required parameter. We can call it. Suppose I want to call that function in some other program, then how we can do that? If we want to do that, that's where we call the concept of module. Okay, concept of modules. Suppose if you want to reuse any functions or any part of the program which is written in some other Python program file within the same folder, then we have to use modules. Suppose I have a folder called folder 1. I have a folder called folder 1. Okay, inside this folder I have abc.py and I have xyz.py. If it is in this case, what are the functions which is written in abc.py or xyz.py? We can interchangeably use them. To and fro. Only thing is we need to import this Python program into this one, or if you want to use some function from here, we have to import it here. Or if you want to use some Python function or some of the functionalities written inside this abc.py, then we have to import that Python program here. That's how we have to do this. First of all, let's see what is the purpose of a module. Okay, first of all, see purpose of module. Okay, purpose of module, if you see, functions, they help us to operation code reusability within the same Python program. Code reusability within the same program. Whereas modules, well, same program, but unable to provide the code reusability, unable to provide code reusability across the program. Then the purpose of module is to do the code reusability across the program. Purpose of the module concept is too heavy. Concept is to provide code reusability, across the program. Code reusability across the program. This is the importance of module. It is giving code reusability across the program. Now, if you see what is the definition of a module, you see as a definition. See, we want to say it as a definition. A module is a collection of variable. Okay. Module is a collection of variables. Variable out of the variable, it can be a global variable. Global variable, functions, and classes. Classes and object, those concepts we are going to see in the upcoming sessions. Let's see one by one. Okay. Now, what are the type of? Let's see what are the type of modules available. Okay. Let's see what are the type of modules available. Types of modules. If you see the module system, we can divide them into two categories. One is called the predefined modules, and the second one is called the programmer defined modules. The first one is called the predefined modules. Predefined modules means these are the modules developed by the programmers itself, which is already available globally. Anyone can use these modules across any programs. The second category is called the programmer defined modules, so user defined modules. Depend upon our usage, we can create our own modules and use them across our systems, across our program. That is called the programmer defined modules. Function of this predefined module is to provide some universal requirement. Okay, provides some universal requirements. Reduce the size to 2 so that it will be clear. Some provides some functionality or the in other ways we can say it as role. Okay, role of a predefined module is to deal with universal requirements. Universal requirement. If you see any example, if you want to see, we have built-in functions available, func tools, then math. This is a math module, sorry, then CMath, that is called the regular expression modules are available. Then if you see CX underscore Oracle, to do a connection with the Oracle databases and all, then MySQL connector, these are some of the predefined modules available. Anyone and everyone can use them. Okay. If you see, I have given one thing called this built-in. Okay, there is a specialty about the built-in modules. Built-in. Okay, specialty about the built-in module. This is the if you see this built-in, they are the default. This is the default predefined module. Okay. default built-in module, default predefined module, default predefined module in Python. Built-ins are the default predefined modules in Python. Next, we are going to see what is meant by programmer-defined modules. We are going to see this second category is called the programmer-defined module. Programmer-defined modules. This is the second category of modules. Whenever we have some requirement to define or use some functions or use some global variables or any classes or objects which is defined in one Python program to use in some other Python program in the same folder, then we have to define this for the programmer defined module. That is where it is going to be. Now, why we are using this in the programmer defined modules? So this is to deal with some common requirement. Okay, common requirements. Suppose this won't be a universal requirement, so it is a programmer's requirement to deal with that particular kind of operations. If you see an example, I can give some banking related modules. Okay, one banking related module may not be operational for another banking related modules, and they won't even share them. In such kind of cases, those parties or those developers of that particular banking system can develop their modules and they can reuse them within that particular folder. Suppose another example called OPT generation modules. I'm going to create an OPT generation module that I can use in my own application, and math formulas. So these are the programmer defined modules. This is going to be used by that particular programmer for their own use. What we need to deep dive here is how to create a programmer defined modules. The system defined modules or predefined modules is easy to use them. Just import those modules and all. And what we're going to see is the step for developing the programmer defined modules. Let's go ahead and see that. Developing a programmer defined modules. Step for developing a programmer defined module. That is what our agenda. The first step is define or choose the variable with values. Okay. Define or choose the variables with, that is, those variables without values we don't need to consider to import, right? So there is no value, then there is no meaning to import them as a module. So you can call it as a global variable. Let's take some other color. And second step is define the function for performing the common operation. Once we define the global variable, then we are going to define the function to perform such operations. Okay, define the functions. Define the functions for performing common operations. For performing common operations. I have already discussed why we are required this programmer defined module. We need the programmer defined modules to handle the common operations or common functionalities. Third one is, once it is defined, if you want to define it as a class, then define the classes. Define the classes. Classes functionalities we are going to see in the next topic or upcoming topic. The once it is done, then fourth stage is save the file with um, .py extension. .py extension. We have to save the file with the .py extension. Okay. Once we execute this one, if you execute this file, okay, if we execute the Python file, it will create one compiled version of that Python file. Okay, it will create a compiled version, compiled Python file. This is called, we can call it as a, suppose, example, if you want to see, suppose I have something called abc.py. Compiled version will be compiled version. If you see in that particular folder itself, it will create something called abc. This is my file name, abc.cpython. cpython hyphen, it will be giving that version. Suppose I'm having 3.14314-314.pyc. This will be the compiled version naming format. If you see the exact naming format, compiled version naming format will be like this. File name dot cpython, file name dot hyphen python version 314 is my python version dot pyc. This will be the file name of that compiled Python module. And this is considered as the module name. This is considered as the module name. Once it is compiled, okay, see that particular folder. Once it is compiled, the Python program will create one folder. It will create it will be saved inside a folder. Compiled file, the file will be saved inside a folder called underscore pycache. This is a folder. Inside this folder, we can see this particular abc or abc.cpython 314.pyc. Inside this particular folder, we can see this pyc file or compiled Python version or Python module file. Once we create this one, next thing is we need to reuse them, right? We need to reuse them into some other Python program. That is what we are going to see next. How to reuse them. Technique for reusing the modules. Technique for reusing the modules. Technique for reusing the module. This is what we're going to see next. There are different techniques. Basically, two techniques are available. First technique is called, one thing is called the by using import statement. By using import statement. By using import statement, we can reuse the modules. And the second case is by using xyz module from xyz import statement. Okay, there are two ways we can use. By using either import module, we can use from particular module import these classes or objects or functions. These are the two ways we can reuse this Python modules. Let's go ahead and see one by one. First, what we are going to see is, let's see the technique one. Technique one is using import module. So import statement. Import statement. This is the first technique. There are around 3 to 4 syntaxes available for using this one. We are going to see the syntax one. First syntax. Syntax one is syntax one. In the syntax one, suppose I have some module name. I am going to declare it as import module name. Module underscore. What are the, suppose if it is a module is defined as a math, then I have to use import math. This is import as a single module. Okay, suppose if you want to give an example, import formula, then import math info. These are a few examples. Let's go ahead and see the second syntax. Okay, I have in my, let's say syntax 2. Syntax 2. I have multiple modules available in the same folder. In that case, I can import multiple modules. Suppose if you want to take the syntax, then import, I have to import module name 1, comma, module name 2, comma, etc. Module name. How many modules are there? All the modules we can import one by one, like this, all together in a single statement. Suppose I want to import this formula and math info together, then if you want to see the example, import formula, comma, math info. These two modules we can import them together. Next, let's go ahead and see the third syntax, import with alias. Okay, syntax 3 is import with alias. The second thing is multiple import. Multiple imports. Third one is import with alias. Alias. Alias means short form. Suppose if the module name is a lengthy one, we can shorten them. Suppose if you see the syntax, import module name as alias name. Module name as alias name. If you want to get some example, import formula as f. Here, using this f, you can access the details of the variables available in that particular formula. Another example, then import math info as either as a single word m. Suppose math info, you need to know what it is math info. If you want to give more than one letter also, that's fine. Here I'm giving m for math info. This is with alias. Let's go ahead and see the syntax number 4. Syntax 4 is import multiple modules with alias. We have seen how to import multiple module. Now we are going to import multiple module with alias. Import modules with alias. If you see something as an example, let's see the syntax first. Syntax is import module 1 as alias name, module 1 as alias 1, comma, module 2 as alias 2, etc. Like that, we import multiple modules in a single statement. Suppose if you want to get an example, then import formula as f, import formula as f, comma, math info as mi, math info as mi, like that. We have defined here mi, so I'm just using that same here, mi here. This is how we are importing the modules to reuse them. Now we are going to see the second technique, technique 2. We have already said about, we have two techniques, right? Using the import statement. This is already seen. Now we are going to see from import. Technique 2. Technique 2. From XYZ file or from that module, import. Import ABC. Let's see how can we use this one. Here also we have two type of usages there. One is syntax, one is syntax 1. Why we using this one? Suppose in my Python file, or I have defined some modules there, will be multiple functions will be there. Okay, some files, if you see in real time, particular Python files will have around 20, 30, 50, 60 functions will be available in this. Suppose 1000 lines of code, into which more than 100 functions will be defined. I don't need to import all of them. That is going to be a hectic one for the system. I don't need all of them. I need only a part of the particular file or that particular module. In that case, suppose in my second program need to access only particular file or particular part of a file or a particular variable or a particular global variable or a particular function or call or class, then I need to import only that particular part of that Python module, not all of them. In that case, we can use from XYZ module import ABC functionality. That is what we are going to see. The first syntax is from module. We can import everything. Okay. First syntax is import all from module. Import all functionalities are from module. That is the first functionality. What is the syntax? Import. Sorry, we have to use from. Syntax start from module name. Import, if you want to import all the functionalities of that particular file, then give the asterisk symbol. Okay, give the asterisk symbol. This is the first syntax. If you want to give some example, from formula, import star. In that formula, I have different functions available to calculate different operations. Suppose if you are adding this from formula import star, it is going to import all the functionalities of that particular Python file into this program. And second syntax is, let's see the second syntax, syntax number 2. Syntax 2 is, usually this import star is not recommended in real time, because in every Python file, no need to access all the functionalities of other Python files. It required only the required amount of or required functionality to be accessed. If in real time, we are importing from fast API, we are importing because if you see the fast API itself, it will be having hundreds of functions will be there, classes will be there, variables will be there. We don't need all of them. We need only a few set of them to do that particular operation. Whatever is required for that particular operation, those functionalities only we need to import. In that case, we can use the second one that we call alias. Import specific items with alias. With or without alias, we can use import specific item with alias. That's why I had it in back today. Okay, let it be no problem. And the syntax is from module 1. Module 1, import variable name as alias, then function name as alias, then class name as alias, because in that particular file we'll be having variables will be there, global variables or any other variables will be there, usually global variable. Then functions will be there. Those functions will be accessing this global variable to do this operations and all. We can import those functions here with some alias name, or in such case, some other cases, classes will be there. We need to access that complete classes inside the class. Some function definition will be there inside that. In that function definition, there will be global local variables will be there. A lot of things will be there. We can define in such a way that we can, from that particular module, we can import the variables. If we want to access them in this particular file, then we can access them in this variable. Those variables inside this file using this import from module 1, import that variable, or from module 1, import that function as alias, or from that module 1, import this class name as an alias name. These are the two techniques we can use. Two techniques. First technique, we have 4 different methods. In second technique, we have 2 different methods. So 2 different syntax to use them. Okay. These are the theoretical discussion about these functions. And one more thing is suppose how to reloading the modules. The last thing is reloading the modules. Suppose something happens, so some configuration changes, so some code changes happen in the backend. In that case, if you want to reload this module, then we have to use this syntax is, we have to use some library called import lib. Okay, import lib dot reload. Inside this one, this is a function call. Inside this one, we have to give the module name. If it is calling like this, if you're making any changes in the parent modules, that is immediately going to reflect into this wherever it is being called. This is called a reloading functionalities of a module. This is all about the theoretical concept. Then once it is defined like this, then we have to call reload function wherever it is declared, so that what are the changes happen there, those functionalities will be available here in the new Python file. Let's these are all the theoretical explanation. Hope you understand what we are going to do in these modules. In the next video, what we are going to see is to see them practical. What are the things we have discussed so far? We are going to see them practical. We are going to create custom defined modules first, and we're going to do them practically, how to use this custom defined modules and how this .psc files are being created, and all that we are going to see them practically. Once it is done, then we are going to see the built-in functions. Hope you enjoy this video. See you in the next one. Bye. Have a good day.